So to add and subtract rational numbers, what do we have to do? What's the first thing? If you're to do this by hand, simplify if you can. That usually helps you. But let's just try to add these straight up. Oh God, what's this? Lowest common denominator. I heard like 6 people all put that together. Yeah, lowest common denominator means that your denominator has to be the same number. The denominator is being the number on the bottom. The way you make things the same is through multiplication. So we are going to look at the numbers 3 and 5 and figure out what numbers they both are. So like if you multiply 3 by the number 2, it would become 6. If you multiply it by 3, it would become 9. Multiply it by 4, it would become 12. Multiply by 5, it would become 15. And you can keep going. These are the multiples of 3. The multiples of 5 would be 5 times by 2, you'd have 10. Times by 3, you'd have 15. Times by 4, you'd have 20. And you can go on for both of those. Your job would be to find the lowest number that they both share. The lowest number they both share is 15. That's called your lowest common denominator. If I was looking at the number 3, how can I get 3 to become 15? I multiply it by 3 would be times by 5. And what you do to the top, you do to the bottom. Okay, so we multiply that first fraction by 5, because that would get us to 15. The second fraction, we're not going to multiply by 5, we're going to multiply it by 3. And again, if you do to the bottom, you do to the top. That makes your brand new fraction 25 over 15 plus 30 over 15. Now, once you have that done, you can add these two things nice and easy. Sometimes we make a very simple mistake when we're adding and subtracting fractions. What I like to think of it is like, you're adding 15ths, right? So like, if I had, think of it like a test. So if I said you got 25 out of 15 on a question, on a test, and then plus you got 30 out of 15 on that same test, and you want to add your scores together, you would say that you got 55 out of 15. Like that would be your 15ths. You'd have 55 15ths. You don't add the denominators together. So what you don't do is say 55 over 30. Okay, you don't add the denominators. You leave it as 15. So that would be your answer right there. You'd have 55 15ths. Better examples are when it's smaller numbers. So if you had like halves or quarters, you wouldn't add the denominators together. Yeah. Yeah, and like if you were to do this on a computer, just a calculator, right? And math bracket to make it simplest form and stuff like that. But for this, we're just trying to remember how to get lowest common denominators. And we're getting lowest common denominators by multiplying to get something that's on the bottom.
If you accidentally didn't do the very lowest, but then you have to.
That'd be good. Yeah, and that would happen on this question. Just because you could have simplified it earlier, which I think Sarah said. Something else to take note of. If you're having a hard time remembering lowest common denominators and how to get the lowest common denominator, you can look at the denominators and say, this one has a 3, so this one needs a 3. This one has a 5, so this one needs a 5. And you're going to hear me use that terminology a lot more once we're doing rational expressions, which are a little bit more challenging. Okay, if we look at this second one, if I want to add and subtract that, I need to find the lowest common denominator. So I have the number 7 and the number 2. So the lowest number they both multiply into would be 14. The way I would turn this first one into 14 is I would go 2 times. And what I do to the bottom, I do to the top. The other one, you'd be timesing by 7. And again, that same trick of this one had a 7 on the bottom, this one needs a 7 on the bottom. This one had a 2 on the bottom, this one needs a 2 on the bottom. Like that could also work to get your lowest common denominators. If you actually do the multiplication, you end up with 4 divided by 14 minus 7 divided by 14. Just like adding them, when you subtract them, you just do the top. So you're going to do 4 minus 7 is negative 3 divided by 14. You don't add together the 14s. The denominator just stays the same. You had 4 14ths, and then you subtracted 7 14ths. That would leave you with negative 3 14ths. All right, you giver, and try to find those other two lowest common denominators and see if you can't add them together. So if you're doing those lowest common denominators, the second one should have been 6. The last one should have been 10. Now, you could have done a bigger one on that far right side. Right? You could have done like 20 or something like that. Like this one needed a 2 and this one needed a 10. But the lowest common denominator, if you're doing fractions, would just be realizing they both multiply to become 10. All right. Those tricks that we use to do addition and subtraction of numbers is the same trick we're going to use to stutter 10 more times. So, the addition and subtraction of rationals, getting the lowest common denominator, the same trick has to apply to get the lowest common denominator for rational expressions when we want to add and subtract them. So, I'm going to show you something very important to doing rational expression denominators. And that thing is going to be adding brackets. So, when you look at any question like this, and you've already been seeing me do it for multiplication and division, you must put brackets around everything, such as this. Because I want myself to understand that those things are all packages. So that 4n on the top is a package. That n plus 4 on the bottom, it's a package. It came together. So I'm saying that those brackets create entire packages. The reason I'm going to do that is when I go to get my lowest common denominator, I'm going to use that trick I just talked about before. I'm going to say, I look at this first fraction, it has a package of n plus 4. If I look at the second denominator, it doesn't have an n plus 4 package anywhere in it. So I need to multiply by that package because it's missing. And what you do to the bottom, you do to the top. Like that. So I'm saying that entire package was missing. So I need to multiply by that entire package. Alternatively, if I look at the second fraction, what package does it have? It has an n minus 5. What's the first fraction missing? An n minus 5. And what I do to the bottom, I do to the top. That will give me a lowest common denominator. What I don't want you to do is I don't want you to look at a question like this. And something a lot of people will do is they'll look at that and they'll say, well, this is an n plus 4 and this is an n minus 5, so that means I need to subtract 5 from this one and add 4 to this one. That doesn't work for a lot of reasons. The biggest reason it doesn't work is when we try to get a lowest common denominator, we have to multiply, not add and subtract. Right? That's the biggest reason why that doesn't work. So please don't do that. You have to put brackets around everything. It'll make your life 1,000 times easier. Once you've added brackets around everything and found your lowest common denominator, I like to rewrite things out. So I'm going to rewrite this first fraction as 4n times n minus 5 divided by n minus 5, n plus 4. Now what I'm not going to do is I'm not going to multiply the bottom together. I'm just going to leave it as n minus 5, n plus 4. The top I am going to multiply afterwards. The second fraction, I'm going to just write it out. So it's plus 3n times n plus 4 divided by n minus 5, n plus 4. Something else I'm not going to do. I'm not going to cancel things out right now. So that's another thing people want to do is they look at this and they go, I have an n plus 4 and an n plus 4, and they cancel them out. Well, of course you have an n plus 4 and an n plus 4. You just put those n plus 4s in there. So don't cancel them out once you put them in there. Why did you put them in there? So that you would get a lowest common denominator, so that you could combine these things into one big fraction instead. To do that, you have to be able to add and subtract the top. To be able to add and subtract the top, you need to multiply the top into itself. So you are going to multiply the numerator. The denominator, you're just going to leave in factored form. The reason why we multiply the top and not the bottom is we want to add the tops together. The bottoms just combine into one beautiful thing. So the top, you're going to multiply in, you get 4n squared minus 20n plus 3n squared plus 12. That's your new numerator. Your denominator stays as n minus 5, n plus 4. Distribute. So you're adding these things together, right? So that addition sign is still right there in between them, and you're adding them together. Yeah. So this first thing became these ones. The second one became these ones. Perfect. Yeah. And the bottoms just combined, and you only have to write it once now. Right? Just like we used to do with our fractions before, if I had 1/2 plus 2/2, it became 3/2. The denominator stayed the same. It doesn't need to be multiplied. It doesn't need to be combined or anything. It just stays the same. Combines into one. Now your last step is to add everything across the top together. So if I was to add these things across the top, remember you combine like terms. So that means n squared is added with n squared. 4n squared plus 3n squared becomes 7n squared. Then you look at your other ones, you have negative 20n plus 12n. That's going to combine to be negative 8n. And in the denominator, you still have n minus 5, n plus 4.
If you could stick a GCF on the top, would you?
Yeah, and you want to finish off in factored form just to see if there's anything you can cancel out. You can factor your numerator. What can come out of that numerator? Just an n. So you can factor out an n. You can't always factor after, but sometimes you can. And it's good to check. Because sometimes in the very last step, then you can cancel something. You usually, like 90% of the time, can't, but you still got to check to see if you can.
So what you're saying is that if there was like an n minus 5 on the top,
I could have canceled them out. Yeah, so if I had, instead of 7n minus 8, if that had somehow turned out to be an n plus 4, then I could cancel. All right. That's a lot. That's a lot harder than that multiplying and dividing. So we're going to do another example. We're going to do a lot of examples today. We have a question here. This one's subtraction instead of addition, so it's a little bit different. But the steps are all going to be the same still. So if you're doing a question like this, from the very beginning, from the very start, you're going to follow the same 3 rules that you've always followed. So now let's do this whole question like it's a whole meal deal. The first question is always to factor. Right? That's always your first step. If you don't factor, these things become a lot harder. So always factor is your first step. When I factor, I'm going to end up with 1 divided by x minus 6, x plus 6. That's a difference of squares. Then I'm going to go minus. And the other fraction is still going to be 1 on top. And on the bottom, I'm going to take a GCF out. The GCF I'm going to take out is not just x. I'm going to take out a negative x. And the reason I'm going to take out a negative x is when I take out a negative x, it's going to rearrange my stuff to become x minus 6. So I took out a negative, it reverses the order. And the reason why that was useful for me was I'm noticing I have an x minus 6 in both denominators. That's why I did it. So I kind of was like making a heads up play, figuring out, hey, there's an x minus 6 on this side. I should try to see if I can't make one on the other side. I can't do that, so. Yeah, right? It'd be nice if we could make heads up plays a little better. All right, first step was factor. Second step is NPVs. So, right? You still have to state your NPVs. Your NPVs are things that cause you to divide by 0. So if I look at this question, I would say x cannot equal positive or negative 6. It also can't equal 0. Positive 6 makes the first thing 0. Negative 6 makes the second thing 0. And if I had x equals 0, that would make this blue guy equal 0.
Why didn't we do the...
We were just talking about adding and subtracting, that's all. Now we're just doing a whole question start to finish. Any questions? Factor, NPV, simplify. So now we need to combine these things into one. To combine them into one, you have to have a common denominator because it's a subtraction question. To get a common denominator, you need to look to see what you're missing as entire packages. So I've already underlined the x minus 6 package. It's in both fractions. So I don't need to add it to either side. The next package I have is x plus 6. There is no x plus 6 on this right one. I need to multiply by x plus 6. Top and bottom. Yep. The next one I'm missing is this little x right here. And I'm going to talk about just the x for a second, not the negative sign. Okay, just the x. So this fraction on the right had a single x out front. That means the first fraction should have a single x. You need to add x to the top and the bottom. The reason I'm not talking about this negative, this guy right here. You guys learned something, I think, in like grade 9, maybe grade 10, about what you do if you have a negative on the bottom. I think the term you guys used was floating negative. What do negatives do if they're on the bottom of a fraction? They float themselves up to the top. Okay, so that means this negative just moves its way up here, and now it's a negative 1 up top instead of being on the bottom. Floating negative. Rarely do you have to deal with them, but here's a question we do.
So we're not adding a negative.
Right. So that means you don't have to give a negative to the first fraction because the negative is no longer the denominator, it's in the numerator. It floated to the top.
And anything in factor on the top?
Just negative, like 1. The x doesn't float. Just the negative floats.
But wouldn't it make it positive if it's gone negative?
Yeah, it's going to make it positive once we deal with it all. All right, once we've got a common denominator, we can write these things out again a little neater. So this first guy is going to be 1 times x, that's just x. Divided by x, x minus 6, x plus 6. Minus, this second fraction is just going to become negative 1 x plus 6. That's what's left at the top. On the bottom, you have x, x minus 6, x plus. And you can see we have two fractions with the exact same denominators. Now I'm going to try to add or subtract these two denominators. This one's a minus sign, so I'm going to be subtracting. I'm also going to multiply that negative 1 into the brackets. There's two ways you can do it. Wait, I'm going to describe it as take that negative 1 and multiply it into both things. Or you could also understand that if you're subtracting a negative, that they cancel each other out. But I'm just going to say distribute that negative in and make your life easy. That means I'm now going to have x minus negative x minus 6. So I took that negative 1 and I multiplied it in to make it negative x minus 6. Everybody sees that? Divide by x, x minus 6, x plus 6. Remember the denominator, you don't have to worry about, it just combines to one thing. My final step is going to be to try to combine this numerator. So that red negative sign I have, that's my subtraction from this entire question that stayed in the middle. If I want to subtract a binomial, that means that minus sign has to change to a plus, which means it changes everything to a plus. And then you can combine like terms. So the only thing with subtraction questions that make it a little trickier is if you forget to put brackets around this, then you're only going to be subtracting the negative x. And you will forget to also subtract that negative 6. So that's why those brackets are important, because it goes to both things in the bracket. When you combine them together, you're going to get 2x plus 6. The denominator is still the same. X minus 6, x plus. Again, you could factor the top. If you wanted, you could take a 2 out of it and leave it as 2x plus 3. Or you could just leave it like that, because nothing cancels out. You should factor just to make it one good final step. Yep. For sure. So, factor, NPV, common denominator, combine like terms. Any questions? All right. These, oh, go ahead, yeah. You can't cancel out x because it has to be able to come out of everything, right? And so because there's an x in the 2 but not in the 6, it wouldn't be able to come out. All right, 2 questions for you to try. So give it your best shot. Follow the steps, right? Factor, NPV, simplify. And I'll show my work to the best of my ability up here. First 2. And then I'll talk about the next one really fast. I'll rip through it, and then give you a chance to practice the next one, which is another harder one. So both of these things, my very first step was to factor. I couldn't factor the first one. There's no factoring that needed to happen. So then all I had to do was put brackets around things. Remember, package everything up. Make everything a package deal. Then you figure out your lowest common denominator by figuring out how many of the packages each side's missing. The first fraction was missing a p plus 1. Second fraction was missing a p minus 2. Multiply it to the top and to the bottom. Then you had p plus 1, p minus 1 on the left side. And you had p plus 3, p minus 2 on the right side. You need to multiply those things together separately. So I said FOIL or do an area diagram, whichever one you prefer. Remember I've said like bring scrap paper for this unit. It helps to just be able to nicely factor or nicely multiply on the side somewhere else and then keep your work all organized. It's hard sometimes to do it like in the middle of the question and keep it looking good. If you did that, you should have p squared minus 1 and then p squared plus p minus 6. Once you have multiplied everything together, you can start adding and subtracting like terms. So the p squares go together, the p's went together, and then the constants went together. This final step right here, you should try to factor that. So the 2p squared plus p minus 7, you can't factor it, but you should try. Right? So you should know that if I could have factored that thing and canceled something out at the very end, I should do that. In this case, you can't. Nothing multiplies to be negative 14 and adds to be 1. So that would be your final answer. The other thing is my NPVs, I did write them. I always write them at the top so I don't lose them in all the mumbo jumbo that's happening. The second question, what made people have a hard time was this floating negative. Where did it come from? Why did I do it? I looked at the first question, saw that the E came first, with E and then a number. So I wanted to reverse my other ones. So to do that, I multiplied everything by negative, and then it became E squared minus 9. That's where that floating negative came out from. And then I did difference of squares to change that into E minus 3, E plus 3. I then multiplied everything by the E plus 3 on the left side. The right side didn't need anything. It had everything to the package. I did float the negative to the top to make it negative 3e. When I wrote it all as one fraction, I had minus negative 3e. So minusing a negative is like adding. So it's really like saying plus 3e. So 2e plus 3e was 5e on the top, and then plus 6. Again, I do try to factor that. I can't factor 5e plus 6, but I tried. All right, this hard one. We're going to rip through this one together. I've seen some of you have been doing pretty good. Yeah.
Did you say the next one after?
Yeah, this one you're going to do on your own. This one you're going to try on your own. And then this one you can also try on your own. So the very first step is always the same thing. Factor. You got to factor. So if I factor this thing, it becomes 5x plus 5x minus 5. Plus, the other one's going to become 4, and then x plus 5, x plus 5. Again, it's probably wise to just have some paper on the side to be able to do that factoring and keep it all clean. Second step is always the same. What do we do right after we factor? We NPV. Find the non-permissible values. In this case, x cannot equal positive or negative 5. Negative 5 would make that 0, positive 5 would make that 0. Negative 5 would make that 0, negative 5 would make that 0. Now you move on to the third step, which is simplify. You can't simplify without having common denominators. And the biggest question people were asking as they worked ahead was, well, this has an x plus 5 and this has an x plus 5, so those two are good. This one's got a second x plus 5. So does this first one need a second x plus 5? And the answer is yes. So you need to have everything the same. So you need to do a second x plus 5. Then the second fraction is missing x minus 5. Now that you've got a common denominator, I'm going to multiply on the top. So my 5 will come into my brackets, my 4 will go into my brackets. And I will end up with 5x plus 25 divided by x plus 5 squared, so there are 2 of them, and x minus 5. So that's just a quicker way of writing x plus 5 and x plus 5. The other one's going to become plus 4x minus 20 divided by x plus 5 squared, and then x minus 5. Now that I have common denominators and my numerators have been simplified, I can combine these into one really big fraction. You combine them by adding the numerators, and the denominators just become 1. So I have 5x plus 25 plus 4x minus 20, all divided by x plus 5 squared, x minus 1. Along the top, any like terms I can combine. 5x plus 4x become 9x. 25 minus 20 becomes plus 5. And the denominator stays the same. Okay. Any questions about that? Yeah, you.
So if there's two denominators of the long one,
Yep.
they're the same, just put it different powers.
Exactly. It just make it easier, right?
So if there's like 4 of them, you put it power.
Yep. So if I had like x plus 8 times x plus 8 times x plus 8, I can just go x plus 8 cubed. It's just 3 of them. Any more questions with this one? Okay, I'll do one more big one, and then there's a third question that you can do completely on your own. So if you're looking at this one, your first step is going to be to factor and write out the NPVs. So you can try that on your own right now. Try factoring, then stating the NPVs. Alright, if you factored those things, you should have got n minus 2, n minus 3 in the first fraction, and then n minus 6, n minus 5 in the second fraction on the bottom. Then I wrote out my NPVs, which is n cannot be 2, 3, 6, or 5. Then I go to simplify things. And to simplify things, I need a common denominator, correct? Is there something that we notice before we have to get our common denominator? Yeah, Bronwyn's noticed something very important. You have an n minus 2 and an n minus 2. So if you happen to have two things that are the same fraction, what can you do with those things? They can cancel out. And what that's going to save you is a lot of work. Because this n minus 2 is now not a package I need to worry about putting into the second fraction. So by canceling out before I get my lowest common denominator, you're going to save yourself a bunch of work. Now you're going to move on to your next step, which is try to figure out all the packages. I have an n minus 3 here, that means I need an n minus 3 here. What I do to the bottom, I do to the top. These guys have an n minus 6 and an n minus 5. I'm missing both of those on the left-hand side. So I'm going to have to add in n minus 6, n minus 5. The n minus 2 is gone, so I don't need to worry about it.
Why don't you put in a big note?
Okay, so on the tops, you want to multiply anything together. So we're going to have to FOIL or area diagram this guy. And you're going to have to FOIL this guy, or area diagram, whichever one you want. If you did that in the first fraction, you would end up with n squared minus 11n plus 30 divided by n minus 6, n minus 5, n minus 3 minus, on the right hand side you'd end up with n squared plus n minus 12 divided by n minus 6, n minus 5, n minus 3. Pardon?
These top numbers come first.
So these top numbers are coming from me foiling n plus 4 times n minus 1. So I'm doing multiplying these binomials on the top by each other. And they're creating these trinomials. So if you should do that on a piece of paper somewhere, like do your FOIL or do your area diagram. Does that answer the question or no?
Give me a second, I'll save my questions and answers here.
Okay. By doing that, I now have common denominator on the bottom and like terms that can be added on the top or subtracted. In this case, it's subtracted. So that means I can write this thing as one big fraction. When I write it as one big fraction, I'm going to go n squared minus 11n plus 30. And then I'm going to go subtract. It did? Good. And you had to see it?
Yeah, that's the part I kind of shoot on purpose.
That's fair. Sometimes you just have to do it yourself and see it. When I combine it into one fraction, notice how I put brackets around the second numerator. The reason I put brackets around the second numerator is this is a subtraction question. So that subtraction sign has to go to everything in the second numerator, not just the first thing. And that's easily like the biggest mistake when you do subtraction of fractions, is that people will not put brackets around here and they'll only have a negative n squared. And they won't subtract their n and they won't subtract their negative 12. And that changes things significantly. Again, the bottom is still the same, it's just combined into one. So if you have a negative on the outside, it turns into a positive, and it changes all the other signs. And then you can combine your like terms. But that negative has to come into the brackets and change everything on the inside of the brackets. Combine your like terms, my n squared minus n squared will cancel out. My negative 11n minus another n will become negative 12n. My plus 30 plus 12 will become plus 42. And on the bottom I have n minus 6, n minus 5, n minus 3. You should definitely finish this question off by factoring the top. What can come out of 12 and 42?
Probably 6.
Yeah, go ahead, Henry.
If you don't change them,
Yeah.
and you just leave it as a minus, the way you usually do.
Like, because you have to somehow, if you know to just minus all three things, that's fine. You don't have to show the changing. I just do that so people see it. But yeah, if you're like minus n squared, minus n, minus 12, that's fine. Yeah. That's how I would do it as well, so that's fine. A 6 can come out of all those?
Yeah.
I'm going to take a 6 out, it's 6, negative n plus 7. On the bottom, yep. N minus 6, n minus 5, n minus. On, okay, go ahead. That would be your final answer. These take a lot of practice because there's a lot of algebra. Your answer to your last question is that top one, I believe. This one.
Probably because it's 7 to 12.
Yeah, the 7. So that's the answer to your last one if you want to try it on your own and practice it. I have about 10.